Welcome my dear students. Now today in the second lesson, data representation, I am going to discuss conversions, binary to other number system, decimal, octal and hexadecimal. Now what is the conversion and what is the meaning of this conversion? I will discuss every point thoroughly with you in this video. And this is the definition here, concept of data representation. And in what is this, just it is explained here theoretically. Data and instructions can't be entered and processed directly into the computers using human language. Any type of data, be it number, letter, spatial, symbol, sound or pictures, must first be converted into machine readable form, that is binary. Yesterday also we have discussed that every number system must be converted in binary number system, then only it will be uh, understood by the machine. So in this video we will discuss this. Now first is our this table. This is very important table. In this table first we have to convert the numbers as 0 to 15 in different number forms and in binary. So I have written on the top, it is 8, 4, 2 and 1. With the help of these two, you have to understand that first we will start from 1, 2, then 4 and 8. Upside it is mentioned. Now if I want to change this 0, so 0 is not present upside, you can see. So 0 0 0 0 we will mention. For 1 you can see here 1 is on the top, so downside 1 we will mention. This 1 is not representing upside, this is only the place value, this is representing the place value. For 2 also I am representing the position, just downside 2 I have written 1. And for 3 also I have written 1 downside the 2 and 1 downside that 2 to represent the position only, and we have to add the number 2 and 1 upside. In 4 also I have written 1, just downside 1, and other places I have written 0. Now in 5 also I have written 1 here, and just after that 1 downside there. So this is only the position, this I am showing you the position. Like this we will go and we will convert the number whatever we want, or any number we can convert it, but not more than 15. This is the limitation, because my maximum number is 8 only. Like the second number, if 8 I want, then a downside 8 I have written 1 and others are 0. And the 9, so for 9 I have written 1 downside 8, as you can see, and that side 1 as downside 1. So 8 and 1 we will add, and the same like 10. So 1 I have written downside 8, and 2 I have written downside 2. So 8 and 2 10. Like 11 I have written 1, and 2 and 1 I have mentioned. To 8 and 12 10 and 1 11. So like this we will add the numbers upside and we will mark the position value. If we want to write like 16 17 also we want to change, then we have to write upside just double of 8 here, like 1 2 4 and 8 it is going, so next will be 16. Like this we can go through up to 31. If I will write upside 16, so it will go like this up to 31. So this we have to take care, and we can go like this for our more values also. So whatever the number it is, we can go for the more and more, just double the numbers, like 1 2 4 and 8 and 16 and then 32. Then we can easily change the numbers. Now our first conversion is going on like binary to decimal, and in this conversion I am taking one number in binary form, 1010. This is binary number, and every number is having the positional value. So as you know this, just 2 to the power 0, this is 2 to the power 1, and next is 2 to the power 2, and the next is 2 to the power 3, 2 to the power 3. So like this we will mention the positional value, and whatever the number is not 0, that will be evaluated, means 2 to the power 3. So how it will be evaluated? Now next 2 to the power 2 is 0, so we will simply write 0, and 2 to the power 1 is 1, so 2 to the power 1 we will write it here, and then after also 0, so we will write it 0 again. Now we will evaluate this, and the part which is having 0, that will be removed, because whatever the number will be multiplied by 0, that will be 0, and whatever the number multiplied by 1, that will be the number. And in this 2 to the power 3 means 2 will be multiplied 3 times, so it will be 8 plus 2 equal to 10. 10 is the answer. 10 is the answer. Now like the same for the second example, 1 0 0 1 0, and this is the second example. In this also we will write the positional value. We will start it from 2 to the power 0, 2 to the power 1, then 2 to the power 2, like this we will start. This is 2 to the power 0, 2 to the power 1. This 0 means the number, whatever the number will be multiplied by 0, that will be 0. 2 to the power 2 means it is 2. 2 to the power 3, it is also 0. 2 to the power 4, it will be the value, because 2 to the power will have the number. Now whatever the number is 0, we will left it, because whatever the number will multiplied by 0, it will be 0. So only one number we will consider, 2 to the power 4 plus 2 to the power 1. Now we will multiply this 2 4 times. This you have to remember, 2 into 2 into 2 into 2. This is 4 and this is 4, and then 4 4 16, and plus 2. So this is 18. Like we will solve this question like this, and this 18 is the answer. This 18 is the answer. Now these numbers are having certain concepts, like if it is 2 to the power 0, then its meaning is 1. 2 to the power 1, then 2, then 2 to the power 2 is 4, 3, then 8, 2 to the power 4, then 16, 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7, then it is 128, 2 to the power 8, then it is 256. Like this it will go. It means we have to multiply the 2 up to that number of times, whatever the power it is. Now with this example, again it will be more clear to you. As you know, the positional value, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Always we will start from right hand side. So whatever the values are having 1 positional, that will be considered in this case, and whatever the zeros, we will just remove it, because the number will be multiplied by 0, it will be 0. 2 to the power 4, 2 to the power 3 plus 2 to the power 1 plus 2 to the power 0. Now 2 to the power 4 means we will multiply 2 4 times, so it will be 16. We will multiply 2 3 times, it will be 8. We will multiply 2 only 1, it is 2, and this is 2 to the power 0 1. So we will add this number, 16 plus 8 24, and 2 plus 1 3, then 27 it is. So answer is 27. Like this we will convert the binary to decimal number system. I hope this is clear to you with some examples. Now in the next binary to octal, this is in this case we will just form the groups of 3 binary bits. In this we will not use the powers, we will form the groups of 3 binary numbers, and we will use the table which I have discussed with you before this video, just at the beginning of video, sorry. And with that table you will transform the numbers, you will read the numbers, and you will try to change the number with the group of 3 bits with the help of that table which I have already discussed in the beginning of this video. Now my first example that I have taken is 110101. This we have to change at octal, so it is very easy. We will form the group of 3 bits like that, 3 and this 3 also. Then after we will give the positional values to these numbers. This is 1 2 4 as I have written in the beginning of this video, 1 2 4 upside. Now 0 means 0, so this is 4, this is 2, this is 0, and this in this case 4 to 6 it is, and this side also 4 and 1 because 2 is 0. We will consider the positional values only, so 4 and 1, this is 5. So our octal number is 6 and 5, 6 and 5. So 110101 is having the equivalent octal number as 65. Now with the help of second example, this will be more clear to you that 100111, this we have to change in octal number system. Now again we will form the groups of 3 numbers, so that 3 and this 3, we will start grouping the numbers from right hand side. Remember this point, we will start the grouping of numbers from right hand side. Now we will write 1 2 4. Now this is 4 because upside 2 and 1 is 0. 1 1 1, 4 2 1. Now in this case also we will consider all the 3 numbers because all the numbers are 1 1 1, so 4 and 7. So this is the answer of this question, 4 and 7 with base 8. This is the octal number equivalent to this number. Now with this example this will be more clear to you. Now I am considering such a number which is not having the group of 3 and 3. So in this case we will add some zeros, and adding 0 will not change the values. Left hand side we will change the zeros. So from right hand side we will start making the groups. So first red you can see 110, then blue you can see, then 1 is left, so we will add 2 zeros in this and we will form 3 different groups. Now 1 2 4, yes, and in this case also we will consider only 1 because rest 2 are zeros. Now 4 to 1 here, so all the 3 will be considered because all are 1 in this case, so this will be 7. In the next 4 and 2 will be considered because third one is 0. Now 1 and 7 and 6, this is the answer with base 8. 176, this is the answer. I hope this is clear to you. Now with the help of one more example, this will be more clear to you. In this also we have to add few zeros by our side. Start making group from right hand side, 0 1 0, 0 1 1, and in this you can see 1 is less, so we will add 0 1 1. Next group 0 1 1, third group 0 1 0. Again write 4 2 1 for this. I am showing you the group. I have added 1 0 in this. and this 0 will not affect the value. So 4 to 1, 4 to 1, 4 to 1, and wherever it is 0 that we will leave. So 2 and 1 it is 3, 2 and 1 it is 3, and this is 2 only. So this answer is 3 3 2 with base 8. Now I hope it is clear to you. This is the answer of this question. Now I hope this is clear to you. This conversion is very easy. In binary to hexadecimal, after this octal, we will form the group of 4 bit only. This is the change. We will form the group of 4 bit from right hand side. This you have to remember, and if any digit is less, then you will add 0 simply. That 0 will not make any change in that value. This is very clear. And one more thing, we will give the positional values in this. We will give the positional values in this. Now with the help of this example, 1 0 1 1 0 1 1 1 1. In this we will start making the groups from right hand side of 4 bits. Now this is the 4 bit, and the second group of 4 bit is this in blue color I have shown to you. Now we will write 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. And simply you can write it also 1, 2 and 4 and 8, as I was writing last time, 4 to 1. So here also, with the help of that first table which I have discussed with you at the beginning of the video, 8 4 2 1 here, and wherever it is 1, that part only we will consider, and zeros we will leave. So you can see here 4 to 1 is having the ones that we will consider. So we will add this 4 and 2 and 1, so it will be 7. Now in this also 8 4 2 1 we will write, and we will consider the 1 only. So 8 2 and 1 is having the 1, so we will add 8 and 2 10 and 1, so its addition is 11. And you know this in hexadecimal 11 is having the code. We will not write 11 directly, we will write the code for the 11. So the code for 11 is B, so its answer is B7 with the base 16. B7 with the base 16. I hope this is clear to you. This is the answer of this question. Now with the help of second example, I hope this will be more clear. 1 1 1 0 1 1 1 0 1 0 1. We will start making groups from right hand side of 4 bits. 1 0 1 0, then 1 1 1 0, and you can see here 2 bits are less. No problem, add 2 zeros in this. This will not change the value. This will not change the value. 0 0 1 0 1 1 1 0 1 0 1 0 it is, and again write 8 4 2 1 8 4 2 1. Now wherever it is 1 that we will consider, so in this only 2 we will consider, rest others are 0, so only 2 will be considered. Now in this 8 4 2 1, in this 8 4 and 2, all 3 will be considered because all 3 are having 1, and last we will leave it. So 8 4 12 and 2 14, then 8 4 2 1, again 1 we will consider, so 8 and 2 we will consider, so 8 and 2 10. Now 14 and 10 we will not write directly, we are having the codes now. So 10 and A11B, 12C, 13D. So we will write here 14 is having the E and 10 is having the A code. So 2EA is the answer. 2EA is the answer of this question. So like this we will just make the group of 4 bits from right hand side, and we will evaluate the question. Now with the help of this third question, it will be more clear to you. 1111 Now double one double zero, then 4 times 1, then triple 10, and then you can see 1 is left here, so we will add 3 zeros. Adding 0 will not affect the question, will not affect anything. So 3 times 0 1, then triple 10, then 4 times 1, then double 1 double 0. Now the same process, 8421, wherever it is 1, that we will consider, so 1 it is. Now in this case also 8421, so you can see 8 and 4 and 2 we can consider 842. So 8 and 4 12 and 2 14 is the value. Here all 4 will be considered because 1 is there. 8421, it will be 15, then 8421 again. Now in this also you can add 8 and 4, it will be 12. Now we will not write the numbers directly, we will write the code for these numbers. 12 is having the code C, 14 is having the code E, 15 is having the code F, and 1 is 1. So 1EFC with base 16 is the answer of this question. I hope this is clear to you. This method is very easy. Now we have studied this binary to decimal, binary to octal, and binary to hexadecimal, and this is very easy also, and you have to maintain the notes properly. Write it in your copy. Thank you.